Chain rule for e to the u. If u of x is a differentiable function of x, then the derivative of e to the u of x is equal to e to the u of x times the derivative of u with respect to x. Now, to me, I can understand what that says, but you might understand this a little bit better. The derivative of e to the blob is e to the blob times the derivative of the blob. That's what it says. It's e to the blob times the derivative of the blob. E to the blob times the derivative of the blob. E to the blob times the derivative of the blob. Chain rule. Only the blob now is an exponent. So here we go. I have the derivative of 3e to the 4x minus 1. So f prime of x is 3 times e to the blob times the derivative of the blob. So this is 3 times e to the 4x plus 1, and the derivative of 4x plus 1 is? And I'm just going to leave it there. You can simplify that if you like.
So it would be 12e to the 4x plus 1?
Yes, it would be 12e to the 4x plus 1, yeah. E to the blob times the derivative of the blob. E to the blob times the derivative of the blob. E to the blob times the derivative of the blob. Just a rule that you need to remember.
So why do we keep that 3 in there?
3 is the constant. So it's always a constant times, then you're going to take the derivative of this. Because if I wanted to use product rule on that, what's the derivative of 3? 0. So the second term would drop out. So constant always comes along for the ride.
Okay.
What is the derivative of this guy? Well, f prime of x is e to the blob times the derivative of the blob so it's e to the blob times the derivative of 2x of x squared plus 2x minus 1 is what?
2x plus 2.
And then you can factor out a 2 if you want, that kind of thing. Do you know what the coolest thing about this is? Is e to the x ever 0? No. Who's the only thing in this mess that can ever be 0?
Yeah.
Yeah. This guy's never going to be 0. Now, can that blob be 0? The answer ends up being yes. But e to the blob is never 0. Because he has a horizontal asymptote. So he's never 0. He's always positive. However, the only thing that you need to worry about setting equal to 0 is the 2x plus 2. That's where your zeros are going to come from. It's going to come from the derivative of the blob. Cool. It's a cool thing about E. Woohoo, yay. Whoopee. Oh. See, I just never know why I'm the only one that has fun in math. Okay. Oh my goodness, what is this? Product rule. Right? So f prime of x is the derivative of x, which is just 1, times e to the minus x squared plus x times the derivative of e to the minus x squared is e to the blob times the derivative of the blob. So this becomes e to the minus x squared plus x e to the minus x squared times the derivative of minus 2x minus x squared is and notice again it's got a greatest common factor of e to the blob. And when you factor it out, you've got something that you can solve for x. And then you can simplify that if you like. I didn't leave us enough room to simplify, so. Who's this? Quotient rule. H prime of x. Bring the denominator up times the derivative of the numerator minus the numerator, it's e to the minus x, minus the numerator times the derivative of the denominator all over the denominator squared. So then this becomes x squared times, what is the derivative of e to the minus x? E to the minus x times -1 minus e to the minus x times the derivative of x squared is 2x, right? All over x to the 4th. And again, the greatest common factor is going to be e to the minus x. So if I want to simplify this, I have to be very careful because this next problem takes up some space. So this is going to be minus x squared e to the minus x minus 2x e to the minus x all over x to the 4th. So you could factor out an e to the minus x and actually an x and an e to the minus x, couldn't you? To reduce it down. So you've got a greatest common factor of minus x e to the minus x. You end up with something that you can actually solve. So if I take a look at this guy, the minus x squared, taking the e to the minus x, minus taking the x, taking the e to the minus x, taking the minus, that's a plus.
What happened?
I'm taking a minus e to the minus x. So if you're taking a minus e to the minus x out, I'm taking the minus, I'm taking an x, which leaves me with an x, I'm taking e to the minus x out, I'm taking a minus, which changes that to a plus, I'm taking an x, and I'm taking e to the minus x. You're left with just x plus 2. And what do you see reduces out? Nothing. An x, right? So you're going to end up with minus e to the minus x times x plus 2 all over x cubed. What's the only thing that can be 0?
X plus 2.
X plus 2. That's going to be the beauty of these problems. They're going to clean up like that. Because e to the minus x is never 0. But x plus 2 can be. And x cubed comes from x squared. So x cubed is x equals 0 is a VA. Because in the original problem, it was e to the minus x divided by x squared. So x equals 0 is a VA. Now, if you were in the engineering calculus, this is a guy you'd run into. And you may have seen him in college algebra as well. And in trigonometry, you run into him as well. And he's just quotient rule, right? So I'm not going to simplify him. But f prime of x, bring the denominator up, times the derivative of the numerator. Derivative of e to the x is e to the x, plus the derivative of e to the minus x is what? E to the minus x times, which is -1, right? So bring the denominator up times the derivative of the numerator minus the numerator times the derivative of the denominator. Derivative of the denominator is derivative of e to the x is e to the x minus derivative of e to the minus x is what? E to the minus x times -1 all over e to the x minus e to the minus x squared. Sorry about that. Do you want to see something really cool? What does this minus sign do? Changes this to what? Negative. What does this minus sign do? Changes that to a positive. So you're going to end up with e to the x minus e to the minus x squared minus e to the x plus e to the minus x squared all over e to the x minus e to the minus x squared. And you can't take that denominator out. Why can't I take the denominator out? What's there? Why can't I cancel this thing? Because it's a subtraction, yeah. This is a grouping. Can't do it. Do you recognize something in that numerator, however, which is kind of interesting? What is he? No. Blob squared minus blob squared. What's blob squared minus blob squared?
0.
No. Well, blob 1 squared minus blob 2 squared. Something squared minus something squared.
Squared.
If
Differential.
it's
Difference.
difference
Difference of squares.
difference of squares. It's a difference of squares. So that says you could actually factor that, simplify it down if you wanted to. I know you're probably at the stage you don't want to, but I thought that was interesting. Your algebra, once again, is going to be pushed. So many of you have a lot to do in terms of getting algebra caught up and begin to bolster whatever weaknesses this test is showing you, or even your homework is showing you. Now this is the one, by the way, I always forgot. And fortunately in this class, I think I have one problem on the next test that's this, just for the heck of it. But we don't deal with something other than E. But this is the generalized form. It says if f of x is equal to a to the x, then f prime of x is equal to a to the x times the natural log of a. I always forget the natural log of a. Now that works the same if it's E. If f of x equals e to the x, f prime of x is equal to e to the x times the natural log of e. Anybody remember what the natural log of e is? 1. It's there because it's 1, we just don't put it there. That's why we say the derivative of e to the x is e to the x. But it really is, it's got the natural log of a attached to it. Like I said, you'll run into some couple of problems in your homework and maybe on a quiz that's got that in it. And I think I've got one problem on the test that's got it in there. But other than that, in this class, our focus is primarily just E. Almost everything we do has E, because that's where your application in business is. It's in E. So if I take a look at, oh, by the way, let's see, let's do this guy. Here's your one with chain rule. If f of x is equal to a to the blob, so you kind of think of this as blob, then f prime is a to the blob times the derivative of the blob times the natural log of the base. So when I look at it, it's a to the blob times the derivative of the blob times the natural log of the base. That's what I think when I do a problem just involving a. It's a to the blob times the derivative of the blob, just like with e, times the natural log of whatever the base is. So that's what's in my little puny brain whenever I do a problem. So here we go. F prime of x equals, this is product rule. The derivative of x squared is 2x times 3 to the x squared plus x squared times 3 to the blob times the derivative of the blob times the natural log of the base. And like I said, when I was a student, I always forgot that, the natural log of the base. 2x, 3 to the x squared plus x squared times 3 to the x squared times the derivative of 2x is, or x squared is 2x. And x squared? I guess so. Natural log of 3. And then you can, of course, simplify that if you want to.
And if you don't want to.
Then you don't. On this test, again, when it comes to derivatives, you just take it to the first step. Because I want to know, do you know the process? That's going to be the biggie. Do you know the process? Do you know the process? Do you know the process?